In November of 2024, a team of Italian researchers released the results of an experiment that had been running for over a year in absolute silence on the Giza plateau. They had been firing pulses of synthetic aperture radar through the second pyramid of Giza, the Pyramid of Khafre, and recording, by satellite, what those pulses bounced off of inside the structure. What came back was something no one had been prepared for. The pyramid was not solid. Beneath its base, far below the level any modern archaeologist had ever excavated, were structures that should not have been there. 8 massive vertical wells descending more than 2,000 feet into the bedrock. A hidden complex of chambers and passages far larger than the pyramid above them. And, at the very bottom, what the radar appeared to show was a single, enormous, perfectly geometric structure. A foundation, a platform, or perhaps a chamber, sealed and silent, lying directly beneath the pyramid that has stood on top of it for 46 centuries. The Egyptian government has not yet authorized an excavation. The findings are still under peer review. The methodology is still under debate. Some mainstream archaeologists have called the results impossible. Others have called them inconvenient. But the data is there, and it raises a question that historians of ancient civilization have been quietly avoiding for decades. What if the pyramids were built on top of something that was already there? What if the Egyptians did not invent the pyramid, but inherited it? What if there was a civilization that built the foundations of Giza thousands of years before the first pharaoh ever set foot on the Nile? And what if everything we have been told about the origin of human civilization is wrong by 10,000 years? Tonight, we go beneath the pyramids. You're watching Aeon Archives, the history that was erased, the history that was suppressed, the history that someone at some point did not want us to find. Subscribe before we begin, because what is buried beneath the pyramids of Egypt may rewrite the entire timeline of our species. And it has been waiting for us for 12,000 years. To understand what is happening at Giza right now, you have to understand the story we have been told. The Great Pyramid of Khufu, the largest pyramid in Egypt, the tallest man-made structure on Earth for almost 4,000 years, was built, according to mainstream Egyptology, around the year 2560 before Christ. It was commissioned by a pharaoh of the 4th dynasty named Khufu. We know him in Greek as Cheops. He ruled Egypt for somewhere between 23 and 46 years, depending on which historical source you trust. According to the standard account, Khufu mobilized an army of laborers. Some sources say 20,000, others say 100,000. And over a period of approximately 20 to 30 years, they dragged stone blocks from quarries in Aswan, 400 miles to the south, and stacked them into a structure that is still, today, almost 500 feet tall. 2.3 million blocks. Average weight, 2.5 tons each. The largest blocks, in the King's Chamber, weigh approximately 70 tons. They were positioned, according to the mainstream account, using copper tools, wooden sledges, and inclined ramps. When it was completed, the Great Pyramid was perfectly aligned to true north, with an error of less than 1/15 of 1 degree. It was perfectly square at its base, with corners aligned to within centimeters across distances of 750 feet. It was covered in highly polished white limestone casing stones that, according to Arab historians who saw them before they were stripped in the medieval period, made the entire structure shine like a mirror in the desert sun. This is the version of the story you were taught in school. This is the version that appears in every documentary, every textbook, every guided tour of Giza. This is the version that the Egyptian Supreme Council of Antiquities still officially endorses today. It is also a version with a number of significant problems. Problems that have been quietly accumulating for the past century. Problems that, until very recently, almost no one with a professional reputation in Egyptology was willing to publicly discuss. The first problem is the precision. The Great Pyramid is not just large, It is precise, the kind of precise that does not match what you would expect from copper tools, wooden sledges, and 20,000 laborers. The exterior corners of the pyramid are square to within 7 millimeters across a base of 750 feet. That is a deviation of less than 1/1000th of 1%. To put that in perspective, modern high-rise construction, using lasers and computers, regularly produces deviations many times larger. The internal stonework is even more precise. In the king's chamber, the granite blocks, some of them weighing 70 tons each, have been cut with edges so straight and joined with seams so tight that you cannot fit a credit card between them. The corners of the chamber are millimeter perfect. This is granite, not limestone. Granite is one of the hardest stones on Earth. It cannot be carved with copper tools. Modern attempts to reproduce ancient Egyptian granite cuts have required diamond-tipped saws and high-speed drills. We do not know how the ancient Egyptians cut, transported, or installed 70-ton blocks of granite with the precision of modern industrial machining. The mainstream answer is with copper tools, wooden levers, and a lot of time. Most engineers who have studied the problem do not find this answer satisfying. The second problem is the alignment. The Great Pyramid is not just aligned to true north. It is aligned to true north as it appeared in 2500 BC, which means whoever built it had access to extremely precise astronomical measurement. They knew the rotation of the Earth. They knew the position of the celestial pole. They had instruments capable of measuring angles to a fraction of a degree. There is no record of such instruments existing in Old Kingdom Egypt. There is no record of the mathematics required to perform these calculations existing in Old Kingdom Egypt either. Pythagoras would not be born for another 2,000 years. Euclid would not write the elements for another 2200. The third problem is the granite sarcophagus inside the king's chamber. The sarcophagus is a single block of solid granite, hollowed out and polished smooth on the inside. It is too large to fit through any of the passages leading to the chamber, which means it had to be installed before the chamber was sealed. The walls were built around it. The interior of the sarcophagus shows tool marks consistent, according to engineers who have analyzed it, with circular saw cuts. Saws that, by modern estimates, would have needed to be at least 12 feet long, equipped with hardened cutting edges and rotating at high speed. There is no archaeological evidence for the existence of any such tools in the Egypt of the 4th dynasty. The fourth problem is the casing stones. When the Great Pyramid was first built, it was covered with thousands of polished white limestone blocks that fit together so precisely that, according to medieval Arab descriptions, the seams between them were almost invisible. Most of these casing stones were stripped in the 14th century by Egyptian rulers who used them to build mosques and palaces in Cairo. But a small number remain at the base of the pyramid, and they can still be examined today. The seams between them are less than 1/5 of a millimeter wide. That is the precision of laser-cut industrial machinery, not copper chisels. By the late 1900s, a small but growing number of geologists, engineers, and independent researchers were beginning to ask a question that had been considered, until then, professionally suicidal. What if the people who built the pyramids were not the people we think they were? The most visible question mark on the Giza plateau is not, in fact, the pyramid. It is the Sphinx. The Great Sphinx of Giza is a colossal limestone statue, 240 feet long and 66 feet tall, carved directly from the bedrock of the plateau. It depicts a reclining lion with a human head, traditionally identified as the pharaoh Khafre, son of Khufu, builder of the second pyramid. According to mainstream Egyptology, it was carved around 2500 BC. In 1991, a geologist named Robert Schoch, a tenured professor of natural science at Boston University, made an observation that would derail his academic career and start one of the most controversial debates in modern archaeology. He noticed that the erosion patterns on the body of the Sphinx and on the walls of the trench from which the Sphinx was carved did not look like the erosion patterns produced by wind and sand. They looked like the erosion patterns produced by water, by heavy, prolonged rainfall, by centuries of rainfall, repeatedly cascading down the body of the statue, cutting deep vertical channels into the soft limestone. The problem with this observation was straightforward. Egypt has been a desert for the past 5,000 years. Heavy, prolonged rainfall has not occurred in the region of Giza since the end of what climate scientists call the African humid period, which ended, depending on whose data you trust, somewhere between 5,000 and 7,000 years before Christ. If Schoch's observation was correct, the Sphinx could not have been carved in 2,500 BC. It would have to be at least 7,000 years old, possibly older, possibly much older. Schoch published his findings at the Geological Society of America's annual meeting in 1992. He was joined by John Anthony West, an independent Egyptologist who had been making the same argument for years. They were initially met with academic interest, and then, very quickly, with academic hostility. Mainstream Egyptologists rejected the analysis. They argued that the erosion patterns could be explained by other factors: chemical weathering, salt crystallization, occasional flooding from the nearby aquifer. They pointed out that the Sphinx had been heavily restored over the centuries, that the original surface had been altered, that geological measurements alone could not date a stone monument carved out of natural bedrock. The most prominent of Schoch's critics was Mark Lehner, an American Egyptologist who had spent decades studying the Sphinx. Lehner argued that the erosion patterns were within the range of natural weathering for a structure 4,500 years old, and that the absence of any contemporary inscription identifying a pre-Khafre builder was in itself sufficient evidence to maintain the traditional dating. Schoch was not deterred. He has spent the past 3 decades expanding his analysis. He has examined the erosion patterns at temples in Turkey. He has compared the geological evidence at Göbekli Tepe and Karahan Tepe. He has built a body of work suggesting that humanity's earliest known monuments may be far older than the conventional timeline allows. For most of those 3 decades, mainstream Egyptology dismissed him as a fringe theorist. Then, in 1995, on a hilltop in southern Turkey, an excavation began that would force everyone, including the mainstream, to reconsider what they thought they knew. The hilltop was called Göbekli Tepe. In Turkish, the name means potbelly hill. It was a low rise of land in the Anatolian countryside, about 30 miles from the Syrian border, that had been noted by archaeological surveyors as far back as the 1960s. For decades, the surveyors had assumed it was an ordinary medieval Islamic burial ground. Some scattered stonework, some pottery shards, nothing of significance. In 1994, a German archaeologist named Klaus Schmidt traveled to Göbekli Tepe to see for himself. He had been told that some of the surface stone fragments looked unusually large for a medieval site. What he saw, protruding from the soil, were the upper edges of T-shaped megalithic pillars, stones that had been intentionally shaped, carved with geometric patterns, decorated with images of animals. Schmidt began to dig. Within a year, he had uncovered the upper portions of a circle of stone pillars, each one as much as 18 feet tall and weighing 7 tons. Within 5 years, he had uncovered a second circle, then a third. The site was not medieval, it was not Bronze Age, it was not even Neolithic in the conventional sense. Carbon dating of organic material associated with the lower foundations of the pillars produced a result that nearly broke his career. 11,500 years old. Göbekli Tepe predated Stonehenge by 6,000 years. It predated the Egyptian pyramids by 7,000 years. It predated the development of writing, of agriculture, of ceramics, of cities, of every cultural milestone that, according to the mainstream model of human civilization, should have been required to produce the kind of organized society capable of building it. According to that model, the people who built Göbekli Tepe were hunter-gatherers, small mobile bands, living in temporary shelters, without metal tools, without the wheel, without writing, without organized religion in any institutional sense. These were the people who somehow had quarried multi-ton limestone pillars, transported them across miles of difficult terrain, raised them upright in carefully arranged circles, and carved into them sophisticated symbolic representations of animals, abstract symbols, and what some researchers have argued are astronomical alignments. It should not have been possible. When Schmidt died in 2014, only a small fraction of the site had been excavated. He estimated that more than 95% of Göbekli Tepe was still underground. He believed there were many more circles, many more chambers, many more carvings. The excavation has continued, slowly, since his death. And then, just a few miles away, a sister site was discovered, Karahan Tepe. By every dating method available, Karahan Tepe is even older than Göbekli Tepe. It contains life-sized human statues that, by current estimates, may be the oldest sculptures of the human form ever discovered. It contains what appear to be ritual chambers carved directly into the bedrock. It contains alignments to specific stars, to the rising sun on specific days, that suggest a sophisticated grasp of astronomy thousands of years before mainstream science believed astronomy was practiced. The implications are, by now, unavoidable. 11,000 years ago, somewhere in the hills of Anatolia, a group of people who were not supposed to be capable of monumental architecture were doing exactly that. And it was at almost exactly the same time, 12,000 years ago, that on the other side of the Mediterranean, the rains stopped falling on Egypt, permanently, suggesting that whoever was carving the Sphinx out of the bedrock of Giza may have been working in Egypt's last era of heavy rainfall, 12,000 years ago, long before any pharaoh had ever existed. This brings us to November of 2024. For the past several years, an Italian research team led by two scientists, Filippo Biondi, a remote sensing engineer, and Corrado Malanga, a chemistry professor, have been applying a relatively new technique called synthetic aperture radar Doppler tomography to the Giza plateau. Synthetic aperture radar, usually abbreviated SAR, is a satellite-based imaging technique. It works by firing pulses of microwave radiation at the Earth's surface, recording the reflections and combining many such recordings into a three-dimensional image. It is used routinely for monitoring deforestation, glacial movement, urban expansion, and military reconnaissance. It has the unusual property of being able to penetrate, in some conditions, several meters of solid material, including stone. Biondi and Malanga proposed that the technique could be extended further. By using the natural seismic vibrations of the Earth as an additional signal, and by combining radar reflections with vibrational tomography, they argued, it should be possible to image structures buried at much greater depth than conventional SAR could reach. The Italian team had been using this method with satellites passing over Egypt to look beneath the surface of the Giza plateau, specifically beneath the second pyramid, the Pyramid of Khafre. In November of 2024, they released their preliminary results. What they reported was so unusual that the mainstream archaeological community immediately split into two camps: those who dismissed the methodology as flawed, and those who argued the results were too significant to be ignored without independent investigation. Beneath the Khafre pyramid, the team reported finding 8 massive vertical structures. They described them as cylindrical wells. Each one extended downward into the bedrock to a depth of more than 2,000 feet, over 600 meters. The wells were arranged in a precise geometric pattern, suggesting deliberate construction. Below the wells, at a depth of more than 2,000 feet, the radar imaging suggested the presence of 2 enormous chambers. Each chamber was reported to be approximately 80 meters wide. Each chamber was reported to be connected to the wells above by a series of passages. And at the very bottom of the wells, at a depth that exceeded the height of the pyramid above, the radar appeared to detect something that the team described with carefully chosen scientific language as a subterranean architectural feature of extraordinary scale. A massive structure, larger than the pyramid above it, buried beneath 2,000 feet of solid rock. Most mainstream Egyptologists immediately rejected the findings. They argued that SAR imaging cannot, with current technology, reliably penetrate 2,000 feet of stone. They argued that the patterns the Italian team detected were artifacts, not real structures, but echoes and noise produced by the radar processing itself. The Italian team has continued to defend their methodology. Other independent researchers have reviewed the data and reported that, while the imaging does have limitations, the patterns are too geometrically regular to be explained as random noise. The Egyptian government has not yet authorized an excavation. But the question, once asked, cannot be unasked. What is beneath the second pyramid of Giza, and how long has it been there? The SR scan was not the first modern instrument to detect anomalies inside the pyramids of Giza. Beginning in 2015, a multinational scientific team, calling itself the ScanPyramids project, began applying a different technique called muon tomography to the pyramids. Muons are subatomic particles produced when cosmic rays from outer space collide with molecules in the upper atmosphere. They rain down constantly on the surface of the Earth. They can penetrate stone the way X-rays can penetrate flesh. By placing muon detectors inside, beneath, and around the Great Pyramid, the ScanPyramids team was able to count the number of muons passing through different parts of the structure. Areas of high muon flux indicated less material, that is, voids. Areas of low muon flux indicated more material, that is, solid stone. In 2017, the project announced its first major finding. A previously unknown void had been detected inside the Great Pyramid of Khufu. It was located above the Grand Gallery, the long, sloping passage that leads up to the King's Chamber. It was approximately 100 feet long. It was at least the size of a Boeing 737. It had been sealed inside the pyramid for 46 centuries. No one had known it was there. The discovery was published in the journal Nature. It was peer-reviewed. It was independently verified. It was by every measure of mainstream science a confirmed find. In subsequent years, the ScanPyramids team announced more discoveries. A second smaller corridor near the pyramid's main entrance. Indications of additional voids deeper within the structure. Evidence that the internal architecture of the Great Pyramid is significantly more complex than any modern map of it has ever recorded. The mainstream archaeological response was cautious but accepting. Yes, there were unmapped voids. Yes, the architecture was more complex than previously thought. No, this did not necessarily mean anything more than that the original architects had used internal cavities for engineering purposes, relieving chambers, weight distribution, and so on. But the cumulative effect of these discoveries, combined with Schoch's geological work on the Sphinx, the discoveries at Göbekli Tepe, and now the SAR data from beneath Khafre's pyramid, was beginning to paint a picture that the mainstream had spent decades trying to avoid. The pyramids were not what we thought they were. They were older. They were more complex. They sat on top of structures that had been built before them, by people whose identity we did not yet know. And the more we looked beneath them, the more we found. And it is not only Egypt where these patterns emerge. Across the world, other megalithic sites appear to share architectural features that, by mainstream chronology, should not have been possible at the time they were built. In Bolivia, on a high Andean plateau, sit the ruins of Pumapunku. The site is a complex of massive stone structures, made primarily of red sandstone and andesite, one of the hardest stones in the region. The blocks at Pumapunku are precision cut. The grooves and joints are so geometrically perfect that they appear, to many engineers, to require modern machine tooling to reproduce. Mainstream archaeology dates Pumapunku to approximately 500 AD, the period of the Tiwanaku civilization. But the level of stonework at the site exceeds anything else known from that culture. Some researchers have argued that the most precise sections of Pumapunku may predate the Tiwanaku period entirely, and may represent the work of a much older, lost civilization upon whose foundations the Tiwanaku later built. In Peru, just outside the city of Cusco, sits the citadel of Sacsayhuamán. The lower walls of Sacsayhuamán are composed of limestone blocks weighing as much as 100 tons each. The blocks are irregularly shaped, no two are alike, but they fit together with such precision that you cannot insert the blade of a knife between them. The Inca, to whom mainstream archaeology attributes the site, are not known to have possessed iron tools, the wheel, or the mathematical infrastructure that would allow such precision construction. They themselves, when asked about Sacsayhuamán by Spanish chroniclers in the 16th century, said the site had been built by giants who lived in the land before them. Off the southern coast of Japan, divers exploring the waters near the island of Yonaguni in the 1980s discovered what appeared to be a massive stone structure submerged beneath the sea. The Yonaguni Monument, as it is now called, is a 70-foot tall formation of right angles, terraces, and what appear to be carved staircases. Mainstream geology argues it is a natural rock formation. Other geologists, including independent researchers from Japan's University of the Ryukyus, have argued that the geometry is too regular to be entirely natural, and that, if even partially man-made, the monument would have to date from before sea levels rose at the end of the last ice age, which would make it, like Göbekli Tepe, more than 10,000 years old. In central Turkey, beneath the modern town of Derinkuyu, lies an underground city carved into volcanic rock, 18 levels deep, capable of housing 20,000 people, with ventilation shafts, water wells, churches, livestock stables, and stone doors weighing several hundred pounds each, designed to seal off entire sections of the city from the inside. Mainstream archaeology dates Derinkuyu to the Phrygian period, around 800 BC. But local tradition and the geological characteristics of the lower levels suggest that parts of the city may be considerably older. Each of these sites has been individually disputed. Each has its mainstream defenders and its alternative theorists. But taken together with what we are now seeing at Giza and what was found at Göbekli Tepe, they begin to suggest a pattern in which, scattered across the globe, the foundations of an older civilization may still be visible. Buried, submerged, mistaken for natural geology, attributed to later cultures who did not actually build them, waiting to be recognized. To understand what may have happened, we need to go back further. 12,800 years ago, almost 10,000 years before the first pharaoh ruled Egypt, the planet experienced one of the most violent climate events in the history of human civilization. It is called the Younger Dryas. It lasted approximately 1,200 years. It began with a sudden catastrophic cooling. Global temperatures dropped by as much as 10 degrees Celsius in a matter of decades. The North American ice sheets, which had been retreating for thousands of years, suddenly resumed their advance. Sea levels dropped, coastal regions emerged, inland regions froze. And then, 1,200 years later, at the end of the Younger Dryas, the cooling reversed, almost as suddenly as it had begun. Global temperatures jumped back up by an even greater margin. The ice sheets melted in cataclysmic surges. Sea levels rose by more than 400 feet over the next several thousand years. Coastlines drowned, continental interiors flooded. Mainstream science has been debating the cause of the Younger Dryas for decades. The leading hypothesis, increasingly supported by evidence over the past 20 years, is that the cooling was triggered by a fragmented comet or asteroid impacting the North American ice sheet. Microspherules of impact melted material, layers of platinum dust, burn horizons across multiple continents, the simultaneous extinction of dozens of species of large mammals, mammoths, mastodons, giant sloths, saber-toothed cats. The disappearance of the Clovis culture, the most widespread human population in North America at the time. All of these point to a catastrophic event of global scale. When the warming resumed at the end of the Younger Dryas, the surge of meltwater into the world's oceans permanently submerged regions of land that had been habitable for tens of thousands of years. The Persian Gulf was once a fertile river valley. It is now under 300 feet of water. The North Sea was once a vast plain that connected Britain to mainland Europe. It is now under 300 feet of water. The continental shelves off the coasts of India, Indonesia, Florida, and the Gulf of Mexico were all once dry land. They are now underwater. Geographically speaking, anything human beings built on those coastal lowlands before 12,000 years ago is today lost, crushed by the weight of risen seas, buried under sediment, erased from any direct archaeological record. This has been pointed out repeatedly by alternative researchers, most prominently by the British author Graham Hancock, whose work on the possibility of a lost antediluvian civilization has, over the past 3 decades, moved from fringe to mainstream conversation. Hancock's argument is straightforward. If a civilization existed before the Younger Dryas catastrophe, a civilization sophisticated enough to build monumental architecture, perform precision astronomy, and develop seafaring, most of its physical evidence would now be underwater. The few remaining traces would be found in places that survived. Highlands, inland sites, locations where construction had been substantial enough to outlast millennia of erosion. Places like Göbekli Tepe, places like the bedrock of Giza, places where, if you could only see beneath the surface, you might find foundations laid down by people who had already disappeared by the time the first dynasty of Egypt began to count its years. Let us try to put the pieces together. The Sphinx, by geological analysis, may have been carved from the bedrock of Giza during the African humid period, at least 7,000 years before the date traditionally assigned to it. Possibly 12,000 years ago, when Egypt was still a green and well-watered land. Göbekli Tepe, by carbon dating, was built 11,500 years ago, at exactly the period when, according to one hypothesis, an antediluvian civilization may have been collapsing, and its remnants may have been moving inland to higher ground. Karahan Tepe, by current estimates, is even older. The Great Pyramid of Khufu, by mainstream dating, was built 4,500 years ago. But its precision, its alignment, and its internal complexity have never been adequately explained by the technology available in Old Kingdom Egypt. The new SEAR scans of the Khafre pyramid suggest that beneath the pyramid lie subterranean structures of extraordinary scale, structures that may predate the pyramid itself. The ScanPyramids Mun imaging suggests that the Great Pyramid contains internal voids that have never been mapped, never been entered, and never been accounted for in the official architectural record, and scattered around the world, at Pumapunku, at Sacsayhuamán, at Yonaguni, at Derinkuyu, are sites whose construction defies the mainstream chronology of human capability. The Younger Dryas catastrophe between 12,800 and 11,600 years ago would have erased almost all coastal evidence of any pre-existing civilization, leaving only inland survivors and the foundations of structures built on high ground. Each of these data points, taken in isolation, has been dismissed by mainstream archaeology. The Sphinx erosion is contested. Göbekli Tepe is acknowledged but ascribed to hunter-gatherers. The SEAR data is dismissed as methodological artifact. The voids in the Great Pyramid are explained as engineering features. The younger Dryas impact is increasingly accepted, but its civilizational implications are denied. But taken together, viewed as a single coherent pattern, they suggest something that conventional Egyptology has spent the past century refusing to consider seriously. That the human story did not begin 5,000 years ago. That a civilization existed in some form, somewhere, perhaps in multiple locations, perhaps as a single seafaring culture, perhaps for thousands of years, before any record we currently possess. That the pyramids of Giza were not the beginning of monumental architecture. They were a continuation of it. A late chapter, perhaps the last surviving chapter, of a tradition that began long before the first dynasty of Egypt was ever named. A tradition whose true builders may now lie, sealed and silent, 2,000 feet beneath the second pyramid of Giza. It is fair to ask why, if the pattern is so suggestive, mainstream archaeology has refused for so long to take it seriously. The answer is partly about evidence. There is, in the strict sense, no incontrovertible artifact that proves the existence of a pre-Egyptian civilization. There are anomalies. There are erosion patterns. There are radar anomalies. There are megaliths that defy our understanding of what hunter-gatherers were capable of. But there is no Rosetta Stone of the antediluvian world, no script, no body, no artifact that says unambiguously, "This was made by a people who existed before the rise of Sumer and Egypt." Without that artifact, the orthodox model, that human civilization began approximately 5,000 years ago in Mesopotamia and Egypt, remains the most defensible one in strictly empirical terms. The answer is also partly about institutional structure. Modern archaeology, like all academic disciplines, is built around career incentives. Tenure depends on publishing within accepted frameworks. Funding depends on building on previous work. Reputations depend on careful, conservative analysis. A young archaeologist who publishes a paper claiming the Sphinx is 12,000 years old will not be taken seriously. They will be quietly excluded from grant committees. They will not be cited. This is not a conspiracy. It is just how the social structure of academia works. The result is that fringe ideas, even ideas with substantial circumstantial evidence, tend to be developed by retired professors, by amateur enthusiasts, by independent researchers, and by writers like Graham Hancock, who have built careers outside the academic system. When mainstream science finally does acknowledge a paradigm shift, as it eventually did with continental drift, with bacterial origins of disease, with the asteroid extinction of the dinosaurs, it tends to happen suddenly, after decades of dismissal, after the initial proponents have already died. We may be witnessing the beginning of such a shift right now. The SAR scans at Khafre, the ongoing excavations at Göbekli Tepe, the accumulating evidence for the younger Dryas impact, the ScanPyramids voids, the renewed interest in Robert Schoch's geological work almost 3 decades after he was first dismissed. The pattern is becoming difficult to ignore. And whatever lies beneath the Khafre pyramid, whether it is a chamber, a reservoir, a foundation, or something we do not yet have a name for, its discovery, when it finally happens, will mark either the largest correction in the history of archaeology or the largest confirmation that the orthodox model has been incomplete in fundamental ways. There is a question, finally, that all of this leads toward. What happens to our understanding of who we are if the timeline of human civilization is extended backward by 10,000 years? What does it mean to know that, before our recorded history began, there were people building structures we still cannot replicate today? What does it mean to recognize that we may not be the most advanced civilization that has ever existed on this planet? What does it mean to admit that an entire human era, perhaps as long in years as our own, may have come and gone, and almost nothing of it has survived to be remembered? These are not comfortable questions. They are not the questions a mainstream archaeology textbook is designed to encourage, but they are the questions that the data is now increasingly forcing. If a civilization existed before the younger Dryas, if it ended in catastrophic flooding 12,000 years ago, if its surviving remnants moved inland and built sites like Göbekli Tepe and the foundations beneath Giza, then everything we know about human history is, in some sense, a footnote. We are the inheritors of a story whose first chapters have been deleted. We are the children of a forgotten civilization. And, like all children of forgotten parents, we walk through the world unaware of how much of who we are was already shaped and waiting for us long before we ever arrived. The pyramids are the most visited monuments on Earth. Millions of people stand in front of them every year. They take photographs. They marvel at the scale. They listen to guides recite the official chronology. Almost none of them know that, 2,000 feet beneath the second pyramid, an Italian team has detected what may be the oldest deliberately built structure in human history. A structure that has been waiting for us, in silence, for as long as 12,000 years, and which, if it is ever opened, will tell us something about ourselves that we have spent the last 5,000 years trying not to remember. This was Aeon Archives. If something in this video reached you, subscribe. Because what is buried beneath Giza may be the most important archaeological story of the next decade, and almost no one is reporting on it. In the next video, we follow the cult of Isis from Egypt to Rome, and to a temple complex in southern France where Cleopatra's last priestesses may have escaped the fall of Alexandria. Until then, remember that the pyramids were old before they were ours, and that the past, like all things buried in stone, has a way of refusing to stay buried.